Hi everyone, this is the last video of the test 4 sequence and it is over lesson 8.1. So go ahead and print off your 8.1 notes and we will get started. Okay, so the rest of the notes on this test sequence have been about or the rest of the lessons in this test sequence have been about exponential and logarithmic functions and equations. This one is going to be a little different. We're going to be doing systems of equations, which we haven't done before. But it is really the only thing that's not exponential or logarithmic that's going to be on test 4. Okay, so a system of equations in 2 variables, so all of ours will be in 2 variables, is a set of 2 equations put together. And so what I mean by equations in 2 variables is there is going to be an x and a y variable in both of the equations. Okay, so since we have 2 different variables, x and y, in both of our equations, the solution should solve for x and solve for y. So a solution to a system of equations has an x component and a y component, and that means it can be written as an ordered pair. And in order to solve the system of equations, since there are 2 equations in a system, the ordered pair has to make both equations true. Okay. So our answers are going to be in XY form, and those X and Y's will work for both equations in our system. Okay. So since each of our systems of equations are going to be 2 equations put together, and both of these equations that we're going to be working with are going to be linear equations, we can think of them as being 2 lines. So linear equations represent graphs of lines. So when we have 2 lines together, there's basically 3 different situations that we can have where the lines either match up or don't. And we're going to go over those 3 situations that can happen. So the first situation is the most common one when 2 lines are not parallel. When they're not parallel, they intersect at a single point, so just one. And so that means there's only one solution. So we can see a picture of that if we have 2 lines, they're not parallel. So here's our plane. If we had line number 1, and then line number 2, we would see that they intersect at just one place, right here. And so most of ours are going to be like this. So what you should sort of expect to get out of a system of equations is get one point, one ordered pair. There is, though, another situation that can happen. There would be 2 lines that are parallel but not the same line. So if they're parallel but they're not the same, they never intersect. And so 2 lines never intersect, they never meet at a point, and so there's no point that makes both of them true at the same time. And in that case, there is no solution. And that kind of system that has no solution is called an inconsistent system. So if we have our Cartesian plane set up, and we had 2 lines, line number 1 and line number 2, that are parallel, but they don't are not the same line, then we see that they never meet each other. And since they never meet each other, they have no solution, no crossing. Okay, so we will have just a few problems of this form on Hawks that you may have to ask. So if you end up getting a problem where there's no solution, you would write or click a box that says inconsistent system. Okay, and then the last situation that we have that we're actually not going to have an example of in any of our equations, but it's just sort of a third possibility just to be aware of that it does exist, or two lines that are just the same line written in two different ways. So in that case, they're going to intersect at every single point. And so if every single point is a solution, then that means there are infinitely many solutions. And we call that a dependent system. And so in that case, if we draw our Cartesian plane, and that would be a line and then the exact same line drawn on top. So we see our two lines, they're exactly the same, every single point is the same, and there are infinitely many points that work for that. But we, in this class, are not going to have any dependent systems. So don't put that as an answer. Okay. So I don't have very many examples to work of this, but I'm just going to work a few examples just to show you how it's done of solving these systems of equations and sort of what an inconsistent system would look like. And there are two different methods for solving these equations, so I'll do an example of each method. So the first method is substitution. So with the substitution method, the basic steps of the substitution method is number one, you pick one of the equations and isolate one variable. So get one variable by itself in one equation. So choose one equation and isolate one variable. And so I'm going to do that with this first example. The easiest one to isolate would be this x in the first equation because it doesn't have a coefficient other than 1. So that's the one I'm going to choose to do is in step 1, I'm going to take x plus 7y equals -39. So I'm choosing the first equation and I'm choosing to isolate the x. You could isolate the y if that happens to be the easier one to isolate in one of your examples, but this one, the x, is the easiest one, so that's what I'm choosing. So I'm going to subtract 7y on both sides to get x by itself and get x equals -7y minus 39. Okay? So then our second step should be to plug that, what we just got, into the second equation. So plug answer from step 1 into the second equation, or the other equation. And then solve for the second variable. So that's what I'm going to do. I'm going to take this that we just got, and I'm going to plug it into the second equation, and then I'm going to solve for the other variable, which is y. So in step 2, I'm plugging in x equals -7y minus 39. I'm putting it in for this x here in the second equation. So 3 times x is going to be 3 times -7y minus 39 plus 6y equals -42. So just stuck it in for x right there in the second one. And so now we're going to solve it for y. So we need to distribute that 3, -21y, and then 3 times 39 is 117, so minus 117 plus 6y equals -42. So the 21y and the 6y can combine to make -15y minus 117 equals -42. We'll add 117 to both sides. We'll get negative 15y equals 75. And then we will divide by negative 15 on both sides. And we'll have y equals negative 5. And that will finish up step 2. Okay. So we haven't gotten an ordered pair yet. We just solved for one variable. We have to end up solving for both. So in step 3, we're going to take our answer from step 2 and plug that into, we can choose to plug it into either equation, or really the easiest thing is to plug it into this form that we got in step 1. So I'm going to say plug in answer from the step 2 into either equation. And then we'll solve for the first variable. So I'm going to actually, it's going to be just like sticking it into this first equation. If we stick it into what we got in step 1, it's just now our first variable x is isolated, so it's a little bit easier to put it in. And so I will do step 3, right? I'm going to do it underneath step 2, and then I'll move it in a second. I'm going to do it on the next page. So step 3, I'm plugging in negative 5 into this equation for y. So x equals negative 7 times negative 5 minus 39, which equals positive 35 minus 39, which is negative 4. And then our fourth step is the easiest one, which would be write it as an ordered pair. So we have y equals negative 5 from step 2, and then in step 3, we got x equals negative 4. And so our final answer, we'll just put that as an ordered pair. And so our x value comes first as a negative 4, and our y value comes second as a negative 5. And then I'm going to move this all onto one page so you can see all of it at once, all 4 steps. Okay. And then let me move this over for a second so you can see that too. Okay, so that is the first example, and that ends up being a system with just one solution, negative 4, negative 5. And so we will go on to example 2, and I'm also going to solve that using substitution, which uses the same 4 steps. Okay, so I'll move this back. All right, so we'll do step 1, which is pick an equation and isolate one of the variables. So I'm going to pick this one because that x looks like it would be easy to get by itself, and do x minus 3y equals 11. So we'll add 3y to both sides and get x equals 3y plus 11. And then go on to step 2. Okay, so in step 2, we take this and we will plug it into x for the second equation. So the second equation is negative 2x plus 6y equals negative 24. And so negative 2x, but instead of x, we're writing 3y plus 11. Then plus 6y equals negative 24. So just stuck that right in for x. And now we will solve the equation for y. So I'm going to distribute this negative 2. you get negative 6y plus 11 minus 6y equals negative 24. Sorry, plus 6y here. So now this minus 6y and plus 6y can combine and they end up canceling each other out. So we are just left with 11 on this side, but that means that we have negative 24 on the other side. And we know 11 is not equal to negative 24, so this is definitely not true. So we've sort of arrived at a contradiction in our step 2. So whenever you get a situation like this, where when you try to plug one equation into the other and you get something that doesn't make any sense, like 11 equals negative 24, then you know that you have got an inconsistent system that does not have a solution. So in this case, there's no real way to do steps 3 and 4 of the substitution because you've got something that just doesn't have a solution. So we're going to write inconsistent system here. So inconsistent system is a no solution situation. Okay, so now you've seen what an inconsistent system looks like. It looks like something that just isn't true. So lastly, in this third example, we're going to use a different method, which is the method of elimination. Okay. So I have some steps for elimination. So the first step is you have to multiply one equation or both equations by a number or a couple of numbers that are going to cancel one of the variables. So I'm going to say multiply one or both equations by a number that will cause one of the variables to cancel. Okay, so I'm going to show you what I mean by that. So in this one, we're going to have to multiply both equations. So I'm going to pick a variable to cancel and work on multiplying the equations by something that's going to cancel it. So in this one, I want to cancel my x. I want to get rid of the x and only have y's. So we have 7x and negative 6x there. So it would be great if they had the same coefficient, but just the opposite of each other. So one is the negative of the other. We don't have that, but we can multiply both equations by numbers that are going to force that to happen. So in this one, I'm going to multiply by 6. And then the second equation, I'm going to multiply by 7. And the reason I'm going to do that is multiplying this one by 6 is going to give us a positive 42 in front of our x. And then multiplying this one by a 7 is going to give us a negative 42 in front of our x. And 42 minus 42, that will cancel each other out, and we will end up eliminating that x. So that's what I'm going to do as my first step. So for number 1, I'm first going to multiply both of those, just like I said. So this first equation multiplied by 6, I'm multiplying every single term by 6. So with the first one, 7x times 6 becomes 42x. Negative 2y times 6 is negative 12y. And then 63 times 6, negative 63 times 6 is negative 378. So you may have to use a calculator to get that. I worked this out beforehand. So the second equation, we're going to multiply by 7, and we need to multiply every single term, so all three of those. So negative 6x times 7 becomes negative 42x. Then 7y times 7 becomes plus 49y. And then 91 times 7 becomes 637. Okay, I'm just going to check those calculations really quick by sticking into a calculator. So now we will go on to step 2 of elimination. So step 2 is add the equations together. And step 2 is where the elimination actually happens. So in step 2, we are going to add together this first equation, 42x minus 12y minus 378, plus the negative 42 plus 49y equals 637. So these first two, 42x and negative 42x, cancel out, and we're left with just 0x, or 0. So since it's just 0 there, adding 0 doesn't do anything, so I'm just going to say those totally cancel. Nothing left. Then we have the second one, the second term, negative 12y plus 49y. When we add those together, we get 37y. And then the third terms, negative 378 and 637. When we add those together, we get 259. Okay. So now we can solve for y. So that's what I'm going to do, is solve for the uncanceled variable as step 3. So step 3, I will divide by 37, and we'll get y equals 7. Okay. So for step 4, we will plug what we just got in step 3 into either equation. Okay. So if we look at our original problem, we have 2 equations to choose from. And so in step 4, I'm just going to pick one and plug in y equals 7. And then also part of step 4 is solve for the other variable. Forgot to write that down. Okay, so I'm just going to pick the first equation. I don't have a particular reason for picking that one other than the fact that it just happens to be written first. And I'm going to plug in y equals 7. So we have 7x minus 2y. So that becomes 2 times 7 equals negative 63. And we solve for x there. So we get 7x minus 14 equals negative 63. We can add 14 to both sides. So 7x equals negative 49. And then we'll divide by 7. And we get x equals negative 7 as the answer there. And so now our 5th step, which is the final step, is just to write it as an ordered pair. Okay, so with number 5, I'll just shrink some of this other work, so we'll have room to write number 5 all on the same page. So we have x equals -7 and y equals 7. So our ordered pair has x first is -7 and y second is just +7. And so that is the example using elimination. So any of the systems of equations can be solved using either substitution or elimination. I would suggest using substitution for the ones where x is very easy to isolate, like in the first 2 examples where, or maybe y is easy to isolate. In these first 2 examples though, we had x without a coefficient in both of those, so that was number 1. Then number 2, we also had x without a coefficient. So what I would suggest doing is use substitution for those, because it is very easy to isolate the one variable x, or probably y in some of them. And then if they don't have a variable that is easily isolated, I would suggest using the elimination method. But really, any of the systems of equations that we have can be solved using either method. So also inconsistent system, at some point, I believe it is around step 2 and 3. Once you add those equations together and try to solve it, you're going to end up getting something that is a contradiction. So it'd probably be like 0 equals some number like 5 or something like that. Okay, so that is the end of this lesson, and also the end of the test 4 material. So if there are any questions, feel free to email me or just tune into the Zoom sessions, and just stay safe, and hopefully this will all blow over soon and we'll be able to have normal classes starting next semester.